As the Trump administration pulls back from regulations on climate change, many scientists remain worried about the warming of the oceans, glaciers, and sea level rise. The world's ice is melting faster than previously thought, and it's threatening our planet with potentially massive sea level rise, weather disruptions, and further global warming. A vast expanse of Antarctic ice, roughly the size of Florida, formerly named the Thwaites Glacier. A drone flew over Antarctica's ice shelf, and what it recorded should not exist. In early 2024, an autonomous underwater vehicle called RAN was deployed beneath the Thwaites ice shelf. It descended more than 600 meters, slipped beneath a ceiling of ice hundreds of meters thick, and aimed its sonar upward into a world no human being had ever seen. The team aboard the research vessel expected a smooth, flat surface, ice melting gently and predictably, exactly the way every model said it should. Instead, RAN recorded an inverted landscape of enormous canyons, teardrop formations, and vast hollow cavities where billions of tons of solid ice should have been. The data was so alarming that RAN was sent back even deeper, toward the most critical boundary on the glacier, where ice lifts off bedrock. It never came back, and what it captured before it vanished changes everything we thought we knew about what is really happening beneath the ice. The comfortable lie to understand why what RAN recorded beneath the Thwaites ice shelf shattered everything. You need to know what scientists believe was happening down there for decades. And honestly, what the rest of us still believe right now. Picture this. You're standing on the deck of a modern icebreaker, staring south. Rising out of the black ocean is a sheer white cliff, 30 to 50 meters of solid ice towering straight up, stretching in both directions beyond the limits of sight, like an endless fortress wall. And until recently it was stable, but scientists have discovered a worrying weakness in an ice shelf at the front of the glacier. That is the Antarctic ice shelf. The Ross ice shelf alone covers an area the size of France, and for as long as anyone has studied it, the assumption has been simple. This thing is permanent. It melts slowly from the outside. Air eats at the top. Warm water nibbles at the edges. Slow, predictable, entirely manageable. NASA satellites pass overhead every single day, measuring the ice surface with centimeter precision. Missions like Landsat and Sentinel beam back a continuous stream of imagery. And what do they show? A vast white expanse, largely intact. Maybe a few cracks here and there. Maybe an iceberg calving off the margin. But the overall picture, solid, enduring, under control. The kind of thing that makes governments and research agencies say, "We're monitoring the situation." And everyone nods and moves on with their lives. And that created a dangerous illusion. We told ourselves, if something were going wrong, we'd see it. The satellites would catch it. The models would warn us. We'd have decades to prepare. Here's the problem. We were only looking at the surface when the numbers stopped making sense. The first crack in that confidence wasn't subtle. It was violent. In mid-March 2022, the Conger Glacier's ice shelf, a massive structure in East Antarctica that had survived for thousands of years in what scientists considered the most stable deep freeze on the continent, collapsed entirely. In days. We haven't seen an East Antarctic ice shelf collapse at least in our lifetimes. Over the last, humanum observation period. We're talking about 12,200 square kilometers of ice, an area the size of Los Angeles. Gone. Dr. Catherine Walker, a glaciologist at Woods Hole Oceanographic Institution, called it a warning shot, the kind of event that forces an entire field to rethink its assumptions. Standard thermodynamic models said dismantling a structure that size should take years, possibly decades of sustained warming, but Conger Glacier didn't melt. It shattered, as though someone had kicked out the supports holding up the entire thing, and the whole structure just dropped. In a matter of days, a formation that predated human civilization ceased to exist. That forced researchers to look at their data differently, and when they did, they found something that made no sense at all. See, while optical satellites, the ones that take pictures, kept showing white intact surfaces along West Antarctica, imagine loading that much ice onto trucks. You'd need a convoy stretching from Earth to Mars and back. It is an almost incomprehensible amount of material disappearing annually. But here's the catch. The surface looks exactly the same. No visible drop in height, no shrinking footprint. The satellite photos on the desks of every climate agency in the world showed the same white expanse they showed 10 years ago. This marks the first time in human history that the otherwise frigid region had an ice collapse. Think about that for a second. 50 billion tons vanishing year after year, and you can't see it from above. There's only one explanation. The ice isn't disappearing from the top. It's being destroyed from below in total darkness beneath the ocean surface in a place no satellite lens can reach. The surface we've been watching is a mask, a shell. And behind that shell, something devastating is happening that we were completely blind to. Our most sophisticated observation network, billions of dollars of orbital hardware. Hit subscribe right now because what they sent down into that darkness to find answers is where this story gets truly terrifying. Sending a machine into the void to find out what was happening in that blind zone, Professor Anna Volin and her international team made a decision that no one had attempted at this scale before. They were done trusting satellites. They needed eyes beneath the ice. Their weapon of choice was RAN, an autonomous underwater vehicle of the Hugin class, nearly 7 meters long, shaped like a bright orange torpedo, worth several $1 million, and built to survive one of the most hostile environments on the planet. To give you a sense of what hostile means here, the water temperature beneath the Thwaites ice shelf hovers just above freezing. The pressure at depth exceeds 60 atmospheres. There is zero natural light, and the space RAN would be entering. The cavity between the ice and the seabed had never been entered by any human-made vehicle ever. This wasn't exploration. What that means. Above it, a ceiling of ice hundreds of meters thick. Below it, a jagged seabed that had never been mapped. The moment RAN slipped beneath the shelf, every form of communication, radio, GPS, all of it was cut, gone. The vehicle was completely alone in total darkness, navigating by inertial guidance and compass, with almost no margin for error. Its job was to aim its multi-beam sonar upward and build a three-dimensional map of the underside of the ice. A place that, until that moment, existed only in computer simulations. Doctor, Alistair Graham, a marine geophysicist at the University of South Florida who worked on Thwaites' mapping efforts, described the anticipation aboard the ship as almost unbearable. The prevailing theory said Rand would find a smooth, gently curving surface, like an ice cube melting evenly in a glass of water. The currents underneath were supposed to be orderly, predictable, gentle. Rand came back from its first dives, the data uploaded, and the laboratory fell dead silent. Professor Wolleben later recalled that no one spoke for a long time. The sonar imagery filling the screens bore zero resemblance to any model anyone had ever built. Every prediction, every simulation, every assumption about what the underside of the ice looked like, all of it was wrong. Completely, fundamentally wrong. What appeared on those screens looked nothing like any model anyone had ever built. What the sonar revealed, instead of smooth planes and gentle curves, Rand's sonar painted a picture of absolute chaos. Sharp ridges, deep cross-cutting grooves, sudden, violent changes in depth. The underside of the ice wasn't a passive melting surface. It looked like an inverted mountain range, valleys, canyons, and towering formations all hanging from the ceiling of ice above. But the most disturbing feature, thousands of teardrop-shaped formations, some extending up to 400 meters downward from the ice ceiling, like the stalactites of some frozen underworld cathedral. And here's why that matters. In fluid dynamics, a teardrop is the optimal aerodynamic shape. It only forms when an object is sculpted by a strong, stable, high-velocity flow. The presence of thousands of these shapes beneath Thwaites is physical proof, not a theory, not a model. Proof that the water down there is moving with enormous speed and kinetic energy. Professor Wouters, reviewing the three-dimensional reconstructions, described the realization as chilling. What they were looking at wasn't erosion in any conventional sense. It was demolition, systematic, targeted, and invisible from above. Her team's findings, published in the journal Science Advances, identified the culprit, warm saline currents called circumpolar deep water, driven by Earth's rotation through the Coriolis effect. But here's the deal. These currents don't move in straight lines. They spiral. They produce violent, turbulent eddies that can carry water at temperatures several degrees above freezing directly into contact with ice that hasn't seen warmth in millennia. And when those swirling flows hit irregularities along the ice base, they act like high-pressure hydraulic drills. They don't melt the ice gently from the bottom. They bore vertically and laterally into its structure, carving inverted canyons and thermal conduits that penetrate deep into the core of the shelf. It gets worse. Rignaud's data showed this process is most intense along existing fractures and structural weaknesses. The warm water finds cracks, forces them wider, and hollows out enormous hidden cavities inside the ice, some large enough to contain entire city blocks, while the surface above stays perfectly white, perfectly intact, perfectly deceptive. Those teardrop shapes aren't just geological curiosities. They're scars, battle damage, evidence that Thwaites Glacier is being attacked by a high-energy system that actively hunts for weak points and rips them apart from within. Every single one of those formations is a record of destruction carved over time by currents powerful enough to reshape hundreds of meters of solid ice. And that single discovery blew up everything we thought we knew about Antarctic stability. This isn't a frozen continent slowly softening under sunlight. It's a hollow structure being gutted from below by invisible currents. And the strength of a hollow structure doesn't depend on its overall thickness. It depends on the thinnest point of its shell, the trap beneath the continent. Now, if ocean-driven erosion from below is hollowing out the ice shelf, that's terrifying enough. But it's not the full picture, not even close. Because while Rand was mapping the destruction happening from the ocean side, scientists had already uncovered something equally alarming happening from the other direction, from beneath the continent itself. For years, researchers assumed the Antarctic ice sheet was frozen solid to the bedrock underneath it. Radar sounding and deep drilling shattered that assumption. Antarctica doesn't sit on dry rock. It sits on top of a vast network of more than 600 subglacial lakes, including massive bodies of water like Lake Vostok, which is roughly the size of Lake Ontario and Lake Mercer. These lakes are not isolated puddles. They're connected by extensive subglacial rivers flowing under extreme pressure from the staggering weight of the ice sheet above. Pressure so intense that the water moves through channels carved into bedrock, creating a hidden plumbing system beneath an entire continent. Dr. Helen Amanda Fricker, a glaciologist at Scripps Institution of Oceanography, was among the first to document this phenomenon using NASA's IceSat satellites. Her team observed that in several regions, the ice surface rises and falls by several meters in repeating cycles. The ice is breathing. The lakes beneath are periodically filling up and draining into the ocean, Now, think about that for a second. All that pressurized water at the base, it acts as a hydraulic lubricant. It reduces friction between the ice and the bedrock, turning the entire ice sheet into a colossal sliding raft accelerating toward the coast. So, now put both forces together. From the ocean side, as Rand revealed, warm seawater is hollowing out the structural supports and destroying the frictional anchors at the edge of the shelf. From the continental side, subglacial rivers and lakes are injecting lubrication at the base, shoving the ice toward the sea faster and faster. This is dual foundation failure. The ice shelf, the cork holding back inland glaciers, is being thinned into a fragile shelf from below. And simultaneously, pressure from behind is intensifying as the lubricated ice sheet accelerates. Picture a dam being hollowed out from the front while a rising reservoir pushes harder and harder from behind. Not because the air got warmer, because the architecture holding it up had been secretly demolished from beneath. Thwaites is following the exact same trajectory, but Thwaites is incomparably larger. If Thwaites goes, it doesn't just redraw maps of Antarctica, it redraws the coastlines of the entire world. The machine that never came back. In January 2024, the team launched RAN on a follow-up mission, this time pushing deeper toward the grounding line. That's the most critical boundary in all of glaciology, the exact point where the ice lifts off the bedrock and begins to float. It's where the structural integrity of the entire shelf is decided. And until that point, no instrument had ever reached it beneath Thwaites. RAN descended beneath more than 500 meters of ice. The plan was an extended survey, comprehensive mapping, the data set that would finally tell the world exactly how fast Thwaites was coming apart and how much time we had left. On board the Palmer, the team waited. Hours passed. The scheduled return time arrived. Nothing. The countdown reached 0. The sea stayed flat, silent. Someone rechecked the calculations. Someone else refreshed the tracking interface for the 10th time. The coordinates were correct. The window was right. RAN simply wasn't there. Acoustic locator pings were fired into the water. Emergency signals broadcast into the black void beneath the shelf. No reply. For days afterward, drones and helicopters swept the surrounding ice, scanning for any flash of RAN's bright orange hull surfacing through a crack or lead in the frozen surface. Search teams stared at monitors until their eyes burned. The frozen ocean gave nothing back. RAN was gone. Dr. Karen Haywood, a polar oceanographer at the University of East Anglia, who has worked extensively on autonomous vehicle deployments in Antarctic waters, noted that the loss was devastating, not just financially, but scientifically. RAN was the only instrument capable of direct observation at the grounding line. There is currently no replacement. Technical explanations were offered. Battery failure, navigation error, maybe a software glitch in the guidance system. But given the violent terrain RAN had already documented, a darker possibility haunted the team. The currents may have been too powerful. A turbulent eddy could have slammed the vehicle into the ice ceiling, or a weakened section of that ceiling could have collapsed, sealing the machine in a frozen tomb. RAN never came back, and with it went humanity's only direct eyes at the front line of what may be the most consequential transformation happening on Earth right now. Just as we finally began to see the true shape of the force destroying the ice from within, the door slammed shut. The region carrying one of the greatest collapse risks on the planet is now operating in complete darkness again. We know it's hollowing. We know the erosion is far more violent than any model predicted. But we no longer have real-time data on how fast it's happening, or how close the critical threshold is. And here's what makes that terrifying. The Conger Glacier collapse proved that these failures don't announce themselves. There's no slow fade. There's no warning shot. One day, the structure looks exactly like it did the day before. The next day, it's gone. And right now, at this moment, we have no way to see whether Thwaites is days, years, or decades from the same kind of sudden, catastrophic event. That silence beneath the Antarctic Sea, it's not peaceful. It's the silence of a countdown we can no longer read. The shell. Think back to those breathtaking drone shots you've seen, the ones gliding along the towering ice wall going viral across the internet. Grandeur, permanence, beauty. Now you know what's behind them. A shell, a mask. What RAN recorded before it vanished, stripped away every illusion about what Antarctica actually is. That magnificent white facade is hollow architecture, the appearance of stability held together while its interior is being ripped apart by turbulent currents. For centuries, people speculated about what lay beyond the ice wall. Secret lands, lost civilizations, the edge of the world. But the real question, the one that should keep you up at night, isn't what's behind it. It's what it's made of. Increasingly, the answer is empty space. Antarctic collapse won't look like a slow thaw across centuries. With a hollowed structure and lubricated foundation, it follows the physics of structural failure. Silence, then sudden fracture. One day it holds, the next it doesn't. There is no warning siren. There is no gradual transition. The math of structural failure is binary. The load is either supported or it isn't. And when that shell finally gives, it won't reveal a hidden world. It will release billions of tons of water into the global ocean, reshaping coastlines, submerging cities, displacing hundreds of millions of people. The world after Thwaites collapses does not look like the world before it. The most unsettling images of our time aren't strange lights in the sky. They're sonar maps of inverted canyons beneath Antarctic ice, blueprints of a disaster already in motion, unfolding in a cold darkness so extreme that even our most advanced machines couldn't survive it, let alone return to tell the story. If this changed how you see Antarctica, subscribe and share this, because most people still think that ice wall is solid, and they need to know it's not.